friends, let's solve this problem. Let f be any continuous function on closed interval 0, 2 and twice differentiable on open interval 0, 2. If f of 0 is 0, f of 1 is 1 and f of 2 is 2, then there are four options given. F double dash of x is equals to 0 for all x in open interval 0, 2. F double dash of x is greater than 0 for all x in open interval 0, 2. F dash of x is equals to 0 for some x in closed interval 0, 2. And f double dash of x is equals to 0 for some x in open interval 0, 2. So now we have a f which is a continuous function, in closed interval 0, 2. Okay, and it is twice differentiable on open interval 0, 2. We have f of 0 is equals to 0, f of 1 equals to 1, f of 2 equals to 2. So at these 3 points, we have that f of x has the same value as the function x. Okay, at the point 0, 1 and 2, we have f of x which has the same value as x. So we consider the function f of x minus x and take this new function as h of x. Okay, so now what we have? We have h of 0 is 0, h of 1, we have h of 1 is 0, h of 1 will be 0 because it's f of 1 is 1 and minus 1 is a 0, and h of 2 is also 0, h of 2 is also 0. So here we see that h has a 3 roots. Okay, it has a 3 roots, 0, 1 and 2. F is a continuous function, x is a continuous function, so f minus this function x is also a continuous function. It's a continuous function, and also it's again a twice differentiable because f is a twice differentiable function, x is actually an infinitely times differentiable function, so the subtraction is a twice differentiable function. Okay, so now we can apply Rolle's theorem here. So what Rolle's theorem says? It says that if f is a continuous function from closed interval a comma b to r, if it is a continuous function and differentiable, it's a continuous function and differentiable in the open interval a comma b, it's continuous on closed interval a comma b, it is differentiable on open interval a comma b, and if f of a equals to f of b equals to 0, then there exists some c in the open interval a comma b such that f dash of c is equals to 0. So basically what this theorem says that if f has a root at a and b and it's a continuous and differentiable, then f dash has a root between a and b. Okay, so now let's apply this theorem here. So what we get, that h has a root at 0 and 1, so h dash of x, which is equals to f dash of x minus 1, will have a root between 0 and 1, say a. So let's take it as 0 less than some a less than 1. So it says that h dash of a will be 0, and similarly it has a root between 1 and 2. So let's say 1 less than b less than 2, and we have h dash of b is equals to 0. Okay, now we can apply this same idea to the derivative of h dash, because again the h dash is a continuous function, it has a root a and b. Okay, so between that there will be a root of h double dash. Okay, so now here we have h double dash of x, this is equals to, which is nothing but f double dash of x. Okay, and then this has a root between a and b, so we have some a, say less than c less than b, such that h double dash of c is equals to 0, that's nothing but f double dash of c is equals to 0. Now we have a function h, we have a function f. Now the second derivative of h is same as the second derivative of f, which is nothing but f double dash of x. Okay, so now this says that f double dash of c is equals to 0 for some c in interval 0 comma 2. Okay, for 0 less than c less than 2. So now let's see which option is correct. So the option D is correct. F double dash of x is equals to 0 for some x in close in for some x in open interval 0 comma 2. See, if you want to see why the other options are wrong, because if something is wrong you can construct an example to check that. For example, if I take, like if I take the option C, so I can take my f of x function to be x, which is continuous and it's a twice differentiable. F of 0 is 0, f of 1 is 1 and f of 2 is 2. But if I take f dash of x, which is 1, and it is not equals to 0 for any x in closed interval 0 comma 2. Okay, so like this you can construct some example to show a and b is also wrong. So here we, by our process, we directly got that d is correct.